Hello AAT honors. Today we are going to multiply and divide rational expressions. In our first example, we're going to start using the property of powers in order to expand our denominator. So in our numerator, we have 24a to the 5th b squared over 2 to the 4th, a to the 4th, and b to the 4th. So then when we raise 2 to the 4th power, we have 16 and then a to the 4th, b to the 4th. Next we're going to simplify our coefficients. So we can divide the top and bottom by 8. So in our numerator we have 3, in our denominator we have 2. Now we're going to simplify the a's. If you notice, we have 5 a's in the numerator here and 4 a's in the denominator. If we were to expand that out, 4 of the a's from the numerator will cancel with 4 a's in the denominator. So we'll be left with 1 a in the numerator. For our b's, we have 2 in the numerator and 4 in the denominator. So that means that 2 of the b's in the numerator will cancel out with 2 of them in the denominator, which leaves 2 b's in the denominator. Okay, we're almost done. Now we just have to think, what value could we plug in that could possibly make my denominator equal 0? So you could do this a couple ways. You could set 2b squared equal to 0 and solve. But basically, since it's just that monomial, if I plug 0 in for b, then my whole denominator would equal 0. Therefore, we have to define that b cannot equal 0. And we're all done. In our second example, we're going to start by multiplying straight across. So that means multiplying our coefficients and adding the exponents of our like bases. So we have 60r squared n cubed over t squared over 45r cubed n t to the 4th. So now we can simplify just like we did in the last example. We'll start by dividing our coefficients. So on the top we have 4r squared n cubed t squared over 3r cubed n t to the 4th. And now we can simplify our powers the same way that we did in the last example. So we have 3 r's on the bottom, which will cancel out 2 of the r's on top, so we'll be left with 1 r on the bottom, 2 n's in the numerator, and 2 t's in the denominator. Finally, we have to figure out what could we plug in for the variables to make the denominator equal 0. Well, since we have 2 variables in the denominator in this case, both of those variables could have a value plugged into them. So we would need to say that neither of those variables could equal 0. In this next example, the first thing that we notice is that we are dividing. When you divide fractions, we need to flip it and multiply. So we're multiplying by the reciprocal of the second fraction. So we have x minus 1 on top over x squared plus 2x minus 8 on the bottom. And now we will need to factor. So we'll take this level by level. So the top left, we'll start by factoring. What multiplies to positive 16 and adds to 8 would be x plus 4 times x plus 4. The bottom left, the denominator of that fraction, has a greatest common factor of 2, so we can factor out a 2. The numerator of the next fraction is completely factored, so we just bring that down as x minus 1. And we can also factor the denominator of that second fraction. What multiplies to negative 8 and adds to positive 2 would be x plus 4 times x minus 2. Now that everything is in factored form, we can go ahead and simplify common factors from top to bottom. It's also okay if your common factors occur on a diagonal instead of just one on top of the other, because we could multiply these two fractions so that they go straight across and would become one term, which would then be the same thing. So we can simplify these x plus 4s. We can also get rid of the x minus 1s. And so we're left with x plus 4 over 2 times x minus 2. So you write whatever is left over. Finally, we need to just figure out what could possibly make this denominator equal 0, and that would be if I plugged in positive 2 into this variable here. 2 minus 2 would make this equal 0. And that is our answer. In our fourth example, we have a complex fraction, which is basically a fraction divided by a fraction. But even though it looks a little scary, we're still going to follow the same steps as last time, which is multiplying by the reciprocal of the second. So our first fraction stays as 3n minus 1 over n, and we're going to take the reciprocal of this current denominator. So n to the fourth will now be the numerator, and this trinomial will now be on the bottom, as you can see. So now we can factor before we fully simplify. So starting with the top left, 3n minus 1 is completely factored. The bottom left can actually cross simplify with the n to the fourth, just like we did in our previous examples 1 and 2. So we have 4 n's on top, 1 n on bottom. So this n on bottom will simplify and leave 3 n's on top. And finally, this trinomial on the bottom is going to need to be factored. Since our coefficient of this n squared term is greater than 1, then we're going to need to use the long AC method. So we start by listing our 3n squared. In the middle two terms, we find what multiplies to 9, negative 9, and adds to positive 8. So that would be positive 9 times negative 1 would multiply to negative 9, and 9 minus 1 would be 8. Now we factor by grouping, and that gives us our two factors of n plus 3 times 3n minus 1. So let's rewrite everything so that we can see what can easily be simplified. Well, now that we've factored, we can simplify the 3n minus 1 on top and bottom. So we're left over with n cubed over n plus 3. And finally, n cannot equal negative 3. This last example is a multiplication example, so we do not have to multiply by the reciprocal, but it has a lot of different factoring methods in it. So starting with the m minus 3 squared, I'm going to rewrite that as 2m minus 3's, just so that it looks more completely factored. The denominator of that first fraction can be factored using the shortcut AC, so it multiplies to 9 and adds to negative 6. Would be m minus 3 times m minus 3. The first thing about the next numerator is we can factor out a greatest common factor of m, and we're left with m squared minus 9. Our denominator, m squared minus 9, is a difference of two squares, which factors to m plus 3, m minus 3. So it seems like we're okay to factor, but if we notice, or to cancel, when we notice we still have m squared minus 9. This is not completely factored and can actually be factored again using that difference of two square factor pattern. So we'll carry down the m, and that m squared minus 9 will now factor to m minus 3, m plus 3. So we'll bring down everything else, and then we will cancel common factors. So I can simplify the m plus 3's on the right, m minus 3's, and both sets of m minus 3 on the left, so I'm just left with m. Since I do not have a denominator, I do not need to figure out what would make this undefined, so m is going to be our answer. And that's all. Please make sure that you email me with any questions.